Dr. Sandoval, I've got this IV flow rate problem and I just want to make sure I'm reading it right. It asks to calculate the IV flow rate for 650,000 microliters of D₅W IV over 20.7 hours with an infusion set that has a drop factor of 7 drops per milliliter. Then it asks for the IV flow rate in drops per minute. Is it just a straightforward conversion and calculation, or am I missing some kind of nuance here with the units?
This problem actually packs a couple of unit conversions into one, Priya, especially going from microliters to milliliters, and then hours to minutes for the final answer. It's easy to get those mixed up if we don't start systematically. To begin, let's break down what information we've been given and what we need to find. The problem states you have 650,000 microliters of D₅W to infuse over 20.7 hours. And your infusion set has a drop factor of 7 drops per milliliter. Your goal is to find the IV flow rate in drops per minute. So what do you think would be the very first unit conversion we should tackle to get started?
Okay, so I think we should start with the volume, converting the 650,000 microliters into milliliters. I'm pretty sure there are 1,000 microliters in 1 milliliter, right? I always second-guess myself on those smaller unit conversions.
You are absolutely right, Priya. There are indeed 1,000 microliters in 1 milliliter. That's a crucial conversion for many nursing calculations. Now go ahead and calculate how many milliliters 650,000 microliters would be.
Okay, so if I have 650,000 microliters and there are 1,000 microliters in 1 milliliter, I think I need to multiply. So, 650,000 microliters multiplied by 1,000 microliters per 1 milliliter would be 650 million milliliters. That seems like a huge amount, which makes me think I might have inverted the conversion, but I'm trying to make sense of it.
You're right to question that number, Priya. 650 million milliliters is indeed a very large volume. You've correctly identified that you might have inverted the conversion. Remember, when you're converting from a smaller unit like microliters to a larger unit like milliliters, your numerical value should actually get smaller. Think about it. If 1 milliliter is 1,000 microliters and you have 650,000 microliters, how many groups of 1,000 microliters do you have? You'd divide the total microliters by the number of microliters in 1 milliliter. Can you try setting up that calculation again?
Ah, okay, that makes a lot more sense. My numerical value should get smaller. So, I should divide 650,000 microliters by 1,000 microliters per 1 milliliter. That would give me 650 milliliters. Is that the correct way to think about converting from smaller to larger units?
Yes, that's exactly right, Priya. 650,000 microliters divided by 1,000 microliters per milliliter equals 650 milliliters. You've correctly converted the total volume to milliliters. It's excellent that you caught your earlier inversion and understood why division was the correct operation for converting from a smaller unit to a larger one. Now that we have our total volume in milliliters, what's the next logical step in calculating the IV flow rate in drops per minute?
Okay, so we have the volume in milliliters now. I think the next thing we need to do is convert the time from hours to minutes, since the final answer needs to be in drops per minute. There are 60 minutes in an hour, right? So 20.7 hours multiplied by 60 minutes per hour would be 1,242 minutes.
That's exactly right, Priya. 20.7 hours times 60 minutes per hour equals 1,242 minutes. You've correctly converted the total infusion time into minutes. Now we have our total volume in milliliters and our total time in minutes. What formula or relationship should we use next, bringing in the drop factor, to get closer to our final answer of drops per minute?
Okay, so I think the formula for IV flow rate is total volume in milliliters multiplied by the drop factor in drops per milliliter divided by the total time in minutes. So it would be 650 milliliters multiplied by 7 drops per milliliter divided by 1,242 minutes. Does that sound like the right formula to use here?
Yes, Priya, that's exactly the right formula to use for calculating the IV flow rate in drops per minute. By multiplying the total volume in milliliters by the drop factor, you convert the volume into total drops. Then, by dividing by the total time in minutes, you get the rate in drops per minute. Now go ahead and calculate the IV flow rate using the numbers we've found.
Okay, so I'll do 650 milliliters multiplied by 7 drops per milliliter divided by 20.7 hours. So that's 4550 divided by 20.7, which gives me approximately 219.8. Is that what we're looking for? Around 219.8?
You've set up the multiplication for the total drops correctly, Priya, and the division is right based on the number you used. However, remember our previous step where we converted the total infusion time to minutes for the formula? You used the time in hours again for this final calculation, and the problem asks for drops per minute. Can you recall what the total time in minutes was that we calculated?
Oh, you're right. I used the hours again instead of the minutes. We converted 20.7 hours to 1,242 minutes. My mistake. So, let me try that again. 650 milliliters multiplied by 7 drops per milliliter divided by 1,242 minutes. That's 4550 divided by 1242, which is approximately 3.663 drops per minute. Is that better?
That's much better, Priya. You correctly used 1,242 minutes for your division. 4,550 total drops divided by 1,242 minutes equals approximately 3.663 drops per minute. You've got the correct numerical result of the calculation. Now, thinking about the precision of the measurements we started with, how many significant figures should our final answer have?
Okay, so we have 3.663 drops per minute. I'm thinking maybe 2 significant figures? The drop factor of 7 drops per milliliter only has 1 digit, so I'm wondering if that limits our precision. Would it be around 3.7 drops per minute?
That's a very good thought about precision, Priya, and it's excellent you're considering significant figures. However, the drop factor of 7 drops per milliliter is typically considered an exact count that defines the tubing, not a measured value that limits the precision of your calculation. It won't be the one determining our significant figures. Instead, let's look back at the actual measured values in the original problem. The volume of 650,000 microliters and the time of 20.7 hours. How many significant figures does each of those measured values have?
That's good to know about the drop factor. So, for 650,000 microliters, the trailing zeros without a decimal make me think it's just 2 significant figures, the 6 and the 5. But for 20.7 hours, since the 0 is between 2 non-zero numbers, I'd say that's 3 significant figures. Is that right for both?
You've analyzed that perfectly, Priya. 650,000 microliters, as written, would indeed have 2 significant figures because those trailing zeros are ambiguous without a decimal point. And for 20.7 hours, the 0 between the 2 non-zero digits makes it 3 significant figures. So you're spot on with both. Now, based on the rules for multiplication and division with significant figures, what does this tell us about how many significant figures our final answer should have?
Okay, so since we're using multiplication and division for the IV flow rate calculation, the final answer should have the same number of significant figures as the measurement with the fewest significant figures. In this case, that would be 2, because of the 650,000 microliters. So if my calculation was 3.663 drops per minute, rounding that to 2 significant figures would make it 3.7 drops per minute. Is that the correct final answer?
That's absolutely perfect, Priya. You've correctly identified that since the 650,000 microliters has 2 significant figures, our final answer should also be rounded to 2 significant figures. So, 3.663 drops per minute rounded to 2 significant figures is indeed 3.7 drops per minute. Congratulations, you've solved the problem. To summarize, we started by converting the total volume from microliters to milliliters, then converted the total time from hours to minutes, and finally used the IV flow rate formula with the given drop factor to arrive at 3.7 drops per minute.
Oh, that's great. Thanks so much, Dr. Sandoval. I really appreciate you walking me through this. The unit conversions and remembering the significant figures were definitely the trickiest parts for me. I feel much more confident about these kinds of problems now.